All right, welcome to another episode of HVACR Verse. I'm your host, Kevin Stiles, as usual. Um, so I just had a meeting about diagnosing compressors and stuff with my technicians, and we're getting to that time of year where compressors are failing, right? What I've been seeing is misdiagnosing of compressors, and not just on my technician side, but also other technicians from other companies where people call and get second opinions. Now, if my technician misdiagnoses a compressor, I can usually catch it and I can talk with the customer and say, hey, look, let me take a look at it and make the determination of what actually is going on. But I want to say we're not all perfect. We all make mistakes, but we do need to understand what our tools are telling us and what we're checking and how we're checking it. So to be an example of not being perfect or we all make mistakes, a couple years ago, I was running the commercial side of things, but I was wrapping up early one day and they asked if I'd run a residential call. And I said, sure, not a problem. I'll go out there, find the compressor's not pumping correctly. It's a scroll compressor, but I was like, I don't know what took this out. I checked the outdoor fans running correctly. All the capacitors are good. Indoor fan static pressure is good. It was a little high on the supply, but that was because they had like 3 or 4 registers closed off and we opened them up. Static was like right on point. Coil looked clear, clean. Didn't seem like there was any issues. I did find 2 filter dryers at the air handler. I don't know if that was the problem yet, but I knew something was causing this compressor to prematurely fail, or it was a poor install, because the word from the customer was that they had it installed like a year and a half prior by another company that apparently is out of business now. So, which kind of sucked because they bought a 10-year parts and labor warranty from this company. So we go in and I go, okay, well, on Trane's website, it's still showing your compressor's under warranty as a part. I can get you that part warranted, but this is what's going to be cost for labor. And once we're done, we'll check and make sure everything's running correctly. So, long story short, next day rolls around. I already put the compressor on will call for the technician that's going to go out there. And I just went about doing my thing. And I was once again wrapping up a little bit earlier than anticipated. Some things went my way, and it was being good. And the office said, hey, the technician that was supposed to put that compressor on that house that you diagnosed is running behind. And I said, how behind? And they're like 2 calls behind, and they're both pretty large calls. So I said, okay, I can go pick up that compressor, knock it out, not a big deal. It's like 3 o'clock in the afternoon, whatever. It's not on a roof, it's on the ground, super cool customers, I don't care. I go to Trane Supply, pick up the compressor, start heading towards the customer's house, and I get a phone call from the office. This is where my day started to get sour, and this is why I tell people, try not to let the day get to you. There'll be something bad that happens, and if you let it eat at you for the rest of the day, you're going to make mistakes. So I start heading that way. Office calls me, says, hey, one of our larger customers, they had an ice maker that went down, and it was on their fountain. And if that happens, their fountain doesn't operate properly. And they get angry customers. So I made them a priority. I turned around, went the other direction, went and got the ice maker up and running. And this was like 20 minutes away from where I was sitting at. So get the ice maker up and running, start heading to the customer's house. And I get over there, I recover the refrigerant, and that's where I was like, holy smokes. There is about 9 pounds more refrigerant in this system when I was recovering than what the data plate calls for. And I'm like, the air handler is only 20 feet away. There's no need for this much refrigerant. I go, that's probably what killed this compressor, was being overcharged. So still did my due diligence. I removed the old compressor, swept the system out. I cut the 2 filter dryers out, swept everything out, put 1 filter dryer in, made it all correct, and I Obviously, nitrogen purge while burning the compressor in, nitrogen purge while burning the filter dryer in. And I charge it up by weight from the data plate, start it up, but I was already having a bad evening and it got kind of late. And I started it up and I was like, everything looks good. System had a good split. It was hot in the house. It was like 93 or something in the house. And I had a 23-degree split, which most people would be like, that's phenomenal, right? I didn't look too far into it, didn't check the subcooling. I just went, system was overcharged. I let it run for about 5-10 minutes before I pulled my gauges off, said, it's all good. Walked inside, customer's like, yeah, it's great. It's feeling good in here now. We're not going to die sweating tonight. And I said, perfect. Here's your invoice. They gave me their card, took their payment, and I left, right? I didn't do my due diligence and check through everything to make sure that everything was good. If I had just spent a little bit more time, I would have found something. Well, 2 days go by, customer calls out again, and one of my supervisors go out there, and he goes, hey man, this thing is like pumping down. And I go, pumping down? What do you mean? He goes, it just doesn't make any sense. So I was like, well, what I found was it was way overcharged. And he's like, I have a restriction somewhere. I have to. And I go, well, the filter dryer is up in the crawl space by the air handler. Maybe I did something wrong. Maybe I put the wrong filter dryer in. I go, but I'm pretty sure that I put a biflow in. Shouldn't be an issue. He goes out there and he's doing his thing. And you know what he found? We didn't install it, but there was an external TXV on the system. And he goes, hey, this TXV I don't think is working. He's talking to me on the phone. And I go, just out of curiosity, is there a piston in there? And he pumped the system down, took the cap where the piston goes on the liquid line, pulled that off, and sure enough, there was a piston in there. And if I had just spent about maybe another 5-10 minutes extra checking that system out, I would have caught that. But I didn't do my due diligence, and they could have lost another compressor. Made me look stupid. I called the customer personally, apologized, and they said, we get it. By the time I got out of there, it was like 10:30 or something like that at night. They go, you were tired, you looked pretty beat, so we understand, and we're not upset. And they go, you guys are going to fix it right and make this thing last. And I said, yes, we will. So that leads me into diagnosing compressors properly. And when we replace the compressor, what are the steps we need to do to make sure that compressor is going to last? So,
are you ready?
let's go to my fancy whiteboard right here, right? When we come up to a unit, we always check to see if things are running, right? We do a visual check, and you go to the outdoor unit, and let's just say nothing's running, and you go to the breaker panel, breaker's tripped, or the fuses are blown in the disconnect. So most technicians instantly go, oh, compressor's grounded, right? And they replace the compressor. Come to find out, compressor wasn't grounded, it was something else. So when we're checking compressors, let's just say this is our compressor. It's an amazing compressor right there, guys. Got our discharge right here. Got our discharge right here. I'm going to draw this nice and big so we can see. For all intents and purposes, that's our terminal block on the compressor. So we check from here. Let's just say we check to the copper on the compressor right here, right? And let's say we have 100 ohms. We can say without a doubt that compressor is shorted to ground. And I want to preface it. When we say a grounded compressor, all compressors are grounded. But what we're really meaning to say is it's shorted to ground. And a short is whenever electricity is taking a path unintended or undesigned. So we determine that this compressor is shorted to ground. We're not going to use the term toast because it's not toast, it's shorted. We're not going to use the term blown, because guess what? It's not blown. It's shorted. Use proper terminology, guys. Terminology means a lot to the customer. Now, if they ask for better explanation, let's just go ahead and say whatever we need to. Let's go to that, heaven forbid. Let's say it tripped the breaker and we just automatically assume it's the compressor, right? So we do the same thing. We ohm it out and we get, let's say, 2.8 mega ohms. And what do we go from there? Well, that compressor is not grounded, especially a scroll. I've seen scrolls that are not shorted to ground and they're reading like 1.6 mega ohms. And they're not shorted to ground. I'm just telling you guys. So we don't have a direct short to ground on the compressor. So then we go to our contactor. My amazing contactor right here, right, guys? So we'll say this is our line. And then this is our load. So we can do this through process of elimination, guys. I can take my meter, put it on one of the pins, go to ground, and I have 2 ohms of resistance, right? So 2 ohms. That's pretty much a direct short to ground. What I've done in the past is I start pulling wires off one by one until my short goes away. And then I figure out what that wire goes to. I've seen crankcase heaters be diagnosed as a bad compressor, and we put a new compressor in, and guess what? Still trips the breaker, and it's because the crankcase heater shorted. Seen it probably about a dozen times. I've seen where the terminals, the wire harness going to the compressor is like rubbed through on something, and that's what's shorted to ground. I've seen this stuff happen, and we misdiagnose compressors. And then we still put the compressor in. We're not being honest. Let's be honest with ourselves and be honest with the customer. Hey, I fucked up. Now, this is why we need to check and verify that what we're doing is correct. Now, the other thing I've seen where between your common and run or your common and start is 0 ohms and the compressor is internally shorted. And that's essentially taking a wire from L1 to L2 and just putting it together. That's what that is. So at that point in time, that compressor shorted across common and run or common and start. That's essentially taking a wire, going from L1 to L2 and turn the power on and going boom. Right? So that would still be a compressor needing to be replaced. Now, let's take all this out of the equation. Let's go with, let's say you come to the unit and the outdoor fan's running, but the compressor's not. Well, another amazing drawing of a compressor here. I'm Picasso, guys. So we check the compressor at the terminals of the compressor, and we go from, this is literally what had happened a couple weeks ago. We check from common to ground, and our meter reads OL. I want everyone to understand what OL means on a meter. I've heard people say it means open line, overload. That is not what it means, because you can get OL in volts, you can get OL in resistance, you can get OL reading amp draws. OL on your meter means 0 L's, right? Wrong. It means it's over the limit of what your meter can read. Your meter can't read any higher than whatever it is. So if you're in the ohm scale, for resistance, and it reads OL, that's an infinite amount of resistance that your meter can read. It can't read anymore. So that compressor more than likely is not shorted to ground. So that's not a bad compressor. But then we measure between our common run and common and start, and we find that that's showing OL as well. Well, what does that mean? Our overload's tripped, and the compressor's really, really hot. So we try to cool the compressor down to see what's going on. Get those overloads to close. We get them to close, start the compressor up. Either A, you were taking on liquid and that's what caused the overloads to trip, or if it's a reciprocating compressor, one of the valves failed and it's dumping hot gas back into the crankcase and it's overloading the compressor that way and it's getting hot and tripping. Bearings have failed and it's getting hot and tripping, or the windings are just garbage. And it could have been from a bad install. But at that point in time, we made our due diligence. We know that, hey, it was tripping overloads because it was getting liquid brought back to it. And we go inside and we check the indoor fan, find it not running. Well, no kidding. That's why the customer said it made this really loud noise and then stopped working. So we do all this, and let's just say we've done all our due diligence and we've checked and we made sure everything works on the compressor, or everything's not working the way it's supposed to as far as the compressor goes, and we need to replace the compressor, right? So we replace this compressor, and there's a process to replacing a compressor. But before you even do that, if you can't make the compressor run, there's things you can check before you go about and telling the customer, hey, you need a new compressor. I always check, is the outdoor fan running? Were the starting components good? Is the indoor fan running? Was my static pressure good? If my static pressure is good, coil's clean, air filter's clean, and everything else is working as far as I can tell, I can't check charge yet. Now I know that I have all those items eliminated off the board, so when it comes time to replacing the compressor, there's just a few other things that I need to check to figure out why this compressor failed. Now, if you find that the blower motor is not running, that's a pretty good idea of why the compressor failed. Blower motor is not running, took on liquid, killed the compressor in some form of fashion, right? Then we go into the blower motor is working, but we have 1.3 inches of static. Well, you have no airflow at that point in time. So, took on liquid, killed the compressor. Or you're running your outdoor fan motor, just testing it out, and you check the temperature of the outdoor fan motor, and it's like 150 degrees. And it's 90 degrees outside. That fan motor is failing. Maybe that fan motor is going out, and someone bypassed the high pressure safety on the compressor, and it never tripped head pressure and just kept cooking that compressor and eventually just died. It couldn't handle it. Now you have a determination of, hey, fan motor was bad. Someone bypassed this high pressure safety. Let the customer know I can replace both of these items, get it done. But if I don't at least replace the fan motor, you're going to lose another compressor. Just so you know. That way you can have them prepared. Now, let's say everything's working on that end, but you still have to have the conversation with the customer. Hey, I can get this compressor replaced. This is how much it's going to cost, etc. Once I get this compressor installed, I'm going to go to the system and make sure everything's operating properly to make sure it wasn't just a manufacturer failure, right? So when you get the compressor and you come back, what's the first thing we do? Well, always recover, right? So this is going to give us an indication of some things. I weigh the refrigerant out. That's going to tell me whether I was undercharged or overcharged or right on the money. So if it was undercharged, maybe that compressor was getting too hot and that's why it failed. If it's overcharged, maybe that compressor was taking on liquid. So I can already have a predetermination of what's going on. So I recover the refrigerant, remove the old compressor, remove the filter dryer. I sweep the system out. If it is a burnout, guys, a short, internal short on that compressor, do not reuse that refrigerant. It is contaminated with acid. Just putting it out there. So we swept the system out. ensured that we had a good nitrogen purge while we were burning our compressor in, and a good nitrogen purge while we were burning our filter dryer in. Once we do that, we pressure test and we soap check all our welds. Everything's good, right? We let it sit, do a static hold on the pressure, and then we get rid of that nitrogen and we put it on a vacuum. Now, for those of you that are pulling through your manifolds, stop it. You're wasting your own time. You complain about, oh, vacuums take forever. Most of my vacuums, the longest I've had a vacuum take me, and it was a dirty system, was like half an hour. Okay? And that was a dirty system. I mean, it was filthy. So when we're pulling a vacuum, the first thing I like to do, especially if it's the first time I'm using that pump for the day, check my oil level, make sure my oil level is good. I throw my micron gauge on my vacuum pump. I turn my pump on, and I let it run for a minute. I make sure that it can pull down in a minute. And one of my JB pumps literally pulls down to 8 microns within like less than a minute. Vacuum pump's good. I know if there's any issues, either A, it has to do with my hoses, or it has to do with a leak in the system. So let's just say, for heaven's sake, you can't afford 2 vacuum rated core removal tools. You can only afford 1. So I would put it on the suction side, the larger pipe, pull the core, put at least a 3/8 diameter hose on there if you can't afford another one. Then you can put a quarter hose on the liquid side with a T for your micron gauge. I wouldn't put it on the larger diameter hose because yes, it's going to read a lower micron. So I start pulling a vacuum, not through a manifold, directly to my pump. Once I get down to 500 microns or lower, and I know some of these communicating systems ask for lower than 500 microns, but once I get to 500 microns or lower, I valve off my pump and I check to see, I do a decay test. I watch my rise and I let it sit for about 15 minutes. And if in 15 minutes I hold and I'm steady, what I do is I will start throwing it back on a vacuum again just for fun because I'm going to grab other things. I am cleaning the condenser while pulling the vacuum to make sure that wasn't a problem because we won't know unless the system's running, right? So I get the refrigerant, get my scale, I valve it off, weigh in the charge to exactly what it's supposed to be, start the system up. Now, when we do that, what are we supposed to be doing? You have to let that system stabilize. It's not going to, especially if the house is hot, it's not going to be stable. If the house is like 90 degrees, it's going to take a little bit for that system to come down. Give it like 15, 20 minutes, go start packing your stuff up in your truck that you don't need anymore. Don't put all your stuff away, but you don't need your nitrogen anymore. You don't need your vacuum pump anymore. You don't need this anymore. And I would start cleaning up, making sure my area is ready to go. And then I come back like 15, 20 minutes later. And I'll be checking my superheat at the evaporator to make sure my superheat's okay. TXV systems, I'm checking my subcooling off the chart to make sure my subcooling's okay. And if everything looks good, then either A, it was a mechanical failure or an improper install, and I'm good. But 9 times out of 10, it's something caused that compressor to fail, and we need to figure it out. That's all I want to say. So do our due diligence, diagnose compressors correctly. Don't tell customers compressors are toast or blown or it's a piece of garbage, whatever. Whether you're a Train fan, Carrier fan, Rheem fan, Rudd fan, or Lennox fan, or Goodman, just do your due diligence. Be honest. Let the customer know. I mean, I've seen contactors cause compressors to fail. I've seen systems that were short cycling. I had a Carrier unit that it was maybe 3 years old. Compressor failed. And I didn't diagnose the compressor, but I verified. I always verify now because I've gone to so many compressors that were not bad, and I've replaced them, and I found what was bad, and it irritated me. So now I always double check diagnosis if I didn't diagnose the compressor. But I go to this compressor, sure enough, it is grounded. It's shorted to ground. So I check it out, and then I'm like, okay, start recovering, remove the old compressor, put the new compressor in. I follow my normal procedures, and I start the system up. And I started cleaning my stuff up. And I go back to the unit, and I'm like, why is this thing off? I had that thermostat set for 72 degrees. I know it's 89 in that house right now. Why did it shut off? And I'm picking up a couple more things, and I'm walking to the thermostat, and the thermostat says loss of power. It's a Nest. And I'm like, it's weird. So let it go through its 15-minute time delay or whatever it does. And I go back out to the outdoor unit, and it starts up. And it runs for about 2 minutes and then shuts off. And I'm like, what is going on? Well, the system was short cycling, not because of a system problem, but because the customer had solar installed on their house, and they had a solar shedding program. I don't know if anybody's ever heard of this, solar shedding, where if what they were doing is the installation company, the electrical company, they installed it so if the outdoor unit drew too many amps, and this was based upon their supposed usage, they killed power to the indoor unit so that way it wouldn't continue to run. And it was going through this vicious cycle. I watched it do it 6 times before I was like, I know what's going on now. So I went to the customer. I was like, hey, do you have any kind of software on your phone or anything that you can operate your energy management from your house for your solar system? Oh, I got to call the company is what he said. And we called and found out that the kilowatt usage that they had set up for the outdoor unit was way too low. And that was why the compressor failed. But if I would have just thrown it in, wrapped up, and said, I know the compressor's good, and walked away, that compressor would have died again within a couple years. And I asked him, I said, how many times does this do this during the summer? He goes, ever since I had my solar installed, that thermostat always pops that error message up at the hot time of the day. So do our due diligence, check everything out, make everything right, be good at it. So I hope this helps everybody out. Follow procedures, properly diagnosing compressors. Don't say they're toast. Don't just go, it's a hot piece of garbage. Check it out, make it right, do the right thing for the customer. If you like this channel, subscribe, give it a thumbs up, do whatever you can. I'm trying to make it as better as possible. I'm not the best person in the world, but I'm trying. Well, you guys have a good rest of your day or evening, and thanks for tuning in.